Hello, am I audible, ma?
Yes, ma'am.
Yes, ma'am.
Okay. So, in today's class, we are going to discuss the OPP mock question. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
So, we are going to solve the mock question today, programming question. So, first question is write a C program that reads the coordinates of the point x and y as integers and determine in which quadrant the point lies. Assume that neither of the coordinates will be 0. Both x and y are positive. Print quadrant 1. If x is negative and y is positive, quadrant 2. Both x and y are negative. Quadrant 3. If x and y are negative, then quadrant 4. So the two integers x and y respectively is the input. Okay. Let us solve. So we are given two coordinate points, say x comma y. So these are given to you. Okay. So you need to display in which quadrant it belongs to. So in general, quadrant one, quadrant one, both x and y are positive. X comma y will always be positive. Whereas in the second quadrant, x is negative and y will be positive. Whereas for the third quadrant, both x and y will be negative. Both x and y will be negative. For the fourth quadrant, x is positive and y is negative. Okay. So this is based on we need to read the xy values. Based on the xy values, uh, whether they are positive or negative, we need to display the respective quadrant value. Okay. So first read the, we will solve the problem here. First, you need to read the values of x and y. So you declare x comma y. Okay. So X value, Y value, you read it, scanf statement. So which will read the X and Y values. So declare both X and Y as integers and then read the values of X and Y. Okay. So here we are given that they are not 0. So you need not check for origin or only. So you need to check for the first quadrant. If you want to check for the first quadrant, in the first quadrant, your P value will be greater than 0 because both are positive. So your P will be greater than 0 and also Q will also be greater than 0. So then we need to print it is quadrant 1. Suppose if any one of this fails, else if for the second quadrant, P will be negative, so like not P, sorry, X and Y are your quadrant, okay, coordinate points. So if X is negative, if X is less than 0, that less than 0 is negative, so okay, Y is greater than 0. So X is negative and Y is positive, then display it is quadrant 2. Else, if both are negative, so both your X is less than 0 and Y is less than 0. If both are negative, then display quadrant 3. So if none of these conditions are satisfied, that means your point will definitely be, generally it will be on x-axis or y-axis or in the origin or in any one of the quadrants. And we are given that, so none of the x and y values are 0. So definitely there is no chance of being in origin or in x-axis or y-axis. Both x and y values are not 0 is given. So we need not check for whether it is in origin or in the x-axis or y-axis. You need to check whether it is in quadrant 1, quadrant 2, quadrant 3 or quadrant 4. If it is not in these 3 quadrants, definitely it will be in quadrant 4. So that's why we have written LC. Else it is in the quadrant 4. Okay. So let us test this. So all our test cases were passed. Okay. Submission is successful. Okay. If any one of your x or y values are 0, then you need to check whether it is in the origin or whether it is in the x-axis or whether it is in the y-axis. That also you need to check out. Okay. So because it is given clearly here that neither of the coordinates x or y value is 0. So we are not checking for that. We are checking only for the quadrant. Okay. Any doubt in this?
Ma'am, if it would have mentioned that the coordinates can be 0, then what would be the format?
Ma? If xy values are 0, you are asking.
Yes, ma'am. Yes, ma'am.
Okay. So if xy values are 0, first you need to check even that conditions also. Okay. If x equal to 0 and y equal to 0, y equal to 0, then you need to say it is origin. Printf origin. It is same, else if only. Okay. Else if x equal to 0 If any one of that is 0, x equal to 0, then it will be in the y quadrant. If y equal to 0, it will be in the x quadrant. Yes, you need to check these 4 conditions. Okay, you need to include those 3 conditions also: x-axis, y-axis, origin. Any other doubt?
No, ma'am.
No, ma'am.
Then we go for the second problem. So, second problem is write a C program that prints a discount based on customer membership level and their purchase amount. These discount rules are given below. So, if you are having a gold membership, if you are a gold member, then if you purchase more than 1,000 rupees, you will get a 20% discount. If you
Excuse me,
purchase
ma'am.
less, hello,
Where I can find this mock OPP?
mark OPP.
Yes, ma'am. Where I can find this?
In your course only, no? There is mark for OPP1. In your course portal, you have this.
Okay.
Ma'am.
Yes.
Ma'am, ma'am, there is a general doubt not related to this. May I ask?
Yes.
Ma'am, for this term, if I don't take C, so is that compulsory to write OPP exam?
If you didn't opt for C programming, then no need of writing the OPP.
Yes, ma'am.
So write a C program. If you are having a gold membership, if you are a gold member, then if you purchase more than 1,000 rupees, you will get a discount of 20%. If you purchase less than 1,000, you will get a discount of 15%. If you are a silver member, so and purchase more than 1,000, you will get a discount of 10%. If it is if you purchase less than 10,000, then you will get a 5% discount. Suppose if you are a regular customer, you are not a gold member or a silver member, you are just a regular customer, then if you purchase above 1,000 rupees, you will get a 3% discount. If it is less than 1,000, then you will get only 1% discount. So you are given an input of which member you are, whether you are a gold member or a silver member or a regular member. So that is indicated using GSR. Gold member means G, silver member means S, regular customer means R. So if you are a gold customer and if you purchase more than 1,200, more than 1,000 rupees, then you will get a 20% discount. So how much amount you have purchased is also given. So there are 2 inputs are given to you. So one is your membership and the other one is how much amount you have purchased. How much amount you have purchased. These 2 are given to you. So, gold member more than 1,000 means you will get 20% discount. 20% of 1,200 will be 240. Okay. So you are asked to display your output truncated to 2 decimal points. After decimal point, you should display 2 digits. Okay. So here first we need to read our input. So so I am indicating which member you are, membership ID. So that I am indicating using M level. M level indicates member level. Okay. So member level is a character. So scanf %C and you read the M level value. And then read purchase amount. So here you can take your purchase amount like an integer because all the test cases were given in integer. So you can take them as an integer, or you can also take them like a float. So I had taken it like a float because the discount is calculated on this amount. So discount is also a float. So purchase amount. So the two inputs are given to you. One is the member level and the second one is the purchase amount. So those two values we have read. Okay. And based on how the discounts were described here, based on the membership. If you are a gold member, you have a different discount, silver member. So first I am switching based on my membership level. So if it is G, case G. So here, even though I have read it like a character, so generally case statement will take only integer values, but every character will have an equivalent integer value in C. ASCII value it will take, ASCII value of G. Okay, so that's why you can write even in the case statements, you can write the characters also, but when you are using a character, it should be put it in a single quote. So your C should identify that it is a character only when it is in a single quote. Okay, so M level value, if it is equal to G, then I am checking the purchase amount. If the purchase amount is less than 1,000 rupees, then you will get a 15% discount. So discount equal to 15. Else discount equal to 20. That means else means if purchase amount is greater than or equal to 1,000, then you will get a 20% discount. And so if the membership is G, I am calculating the discount. How much discount I will get, I am taking. Suppose if it is a silver membership, then you will get a discount of 5 and 10 based on purchase is less than 1,000 or greater than or equal to 1,000. And if you are a regular customer, then you will get a discount of 1 and 3. So that I have specified using a switch statement. Switch. Okay. So it will go to the based on your input, it will go to the corresponding case and take the discount percentages. Now you are asked to calculate the discount amount. So discount amount is equal to purchase amount into discount rate, because of this is a percentage. So to convert into value, you divide that by 100. Okay. So purchase amount into discount divided by 100, you will get the discount amount. And display the discount amount with the 2 decimal places. So that's why I gave here 0.2f. 0.2f means after decimal point it will display 2 digits, up to 2 digits. Okay. So both public and private test cases were passed. Any doubt in this?
Yes, ma'am. How is that G, S, and R shown? Like,
See, G, S, R are the given inputs. So these are the characters. Character. So character means you have to read it like a percentage C. So to indicate that it is a character, you should put it in a single quote.
okay, ma'am.
S is a character, G is a character, R is a character. To indicate that it is a character, you have to put it in a quote.
Yes, ma'am.
Okay. So first it will read the M level value. If the M level value is equal to yes, directly it will switch to this case. And it will perform this when it encounters a break, it will come out of the switch and then calculate the discount and display. Suppose if your M level value is equal to G, it will go to this case G and then find the discount. When it encounters a break, it will come out of the switch statement and then calculate discount and display, like that.
Yes, ma'am.
Ma'am,
Yes.
ma'am, if we put the character inside the parenthesis, then we'll get error
If we put the character,
inside the parenthesis.
means like this.
Yes, ma'am.
No, you should not work. The case statement here, you need to give an integer value. Actually, for a case statement, case space, you should give an integer value. So even though here we are giving a character, so every character will have equivalent integer value in C. So the ASCII value of that character inside while executing, it will take the ASCII value of this particular character. So that will be an integer only. So it will accept. But in the syntax of case, you don't have any brackets or something like that. Okay? Case space
Yes,
and
ma'am.
integer value you have to give. Any other doubt?
No, ma'am.
So then we go to the next. So you have a function. You have a function called total. So it is taking three parameters: start, end, and k as parameters. This function is taking three parameters: start, end, and k. Where start less than end, always the start value is less than end, and the function should calculate and return the sum of all even numbers within the inclusive range from start to end and divisible by 2. Okay. Say for example, you are given start equal to 2, end equal to 14. And k value is given as 3. So first you are asked to find out the even numbers within this range. First you need to find out the even numbers within this range, including 2 and 14 also, including start and end also. So what are the even numbers within that range? It will be 2, 4,
2, 4, 6, 8, 10, 12, and 14.
These are the even numbers within this given range. And among these even numbers, you need to find out those numbers which are divisible by 3. So is 2 divisible by 3? No. Is
No.
4 divisible by 3? No. So
No.
6 will be divisible by 3. So the first number that is divisible by 3 is 6. So 6 plus, and then 8 is not divisible by 3, 10 is not divisible by 3, whereas 12 will be divisible by 3. So 6 plus 12, and 14 is not divisible. So you are asked to find out the sum of all the even numbers in this range which are divisible by k. So we have only two numbers which are divisible by k, the 6 and 12. So if you add 6 and 12, you will get 18. Okay. So that is what you need to find out. Okay. So how will you get the? So you need to first the starting value can also be an odd number. It need not be an even number. So first you check whether the start is a even number or odd number. Okay. So if start mod 2 equal to 0, that means start is an even number. Okay. So let us take a loop variable I equal to start. Yes, if it is not an even number, your I, the loop variable will start from, when the first even number will be start plus 1. Suppose if I gave it like this, start equal to 1, end equal to 14. So what will be the first even number in this case?
2.
2. So that means the start, because start is an odd number, then the first even number will be start plus 1. Okay. Suppose if it is a even number, the first even number will be start itself. So first you check whether start is an even number or odd number and you start it. Now you write a for loop. So we have already initialized the loop variable. Let I be the loop variable means we have already initialized the loop variable. So you need not write the initialization. Whereas what is the condition? Till I less than or equal to end, we need to date each time increase the I value by 2, because if your I is an even number, next even number where it will fall? After 2 numbers. So you can say I equal to I plus 2. Here I equal to I plus 2. Step count will be I equal to I plus 2. Okay. So now our aim here is not only, so this loop itself will find the even number, all the even numbers between start and end. So this I is always an even number. Whatever the I which we are getting for this loop goes, yeah, that is always an even number. Now our aim is we need to find out those even numbers which are divisible by k. So inside the loop you check that if I mod k equal to 0, I mod k equal to 0, then that I is divisible by k. So you take one variable called sum, initialize the sum variable to 0. Initially you put your sum variable to 0. Okay, initialize your sum to 0. Then if your I is divisible by k, so when you divide the I by k, if you get a remainder 0, that means I is divisible by k. So now you add your I to sum. So sum is equal to sum plus I. So do this. Okay. So and then you close your loop so that next even number will be plus 2. Plus 2. Like that it will do up to end. So that means it will generate all the even numbers and you are checking whether that even number is divisible by k or not. If it is divisible by k, then you are adding the corresponding I value to the sum, so that by the end of this loop you will get the sum of all even numbers which are divisible by k. Okay. So this loop itself is generating the even number. Okay. So that is what we have written here. Okay. So you are already given the main. So first we read start value, end value, and the k value. And here we are calling the total function with the start, end, and k, and it is returning an answer, sum of all the even numbers which are divisible by k, and that is displayed here. So this is already given to you, and you are asked to write the total function. So total function takes these 3 parameters. So we initialize the sum to 0 and the loop variable I is declared here. So we are checking whether first the start is an even number or not. If start equal to even number, you start your I from start. If it is not even number, you start your I from start plus 1. Okay. So how long you need to do? You need to do till I less than or equal to n. Each time you increase your I by 2 to get the next even number. So we are starting the I with the first even number in that range, and each time we are increasing it by 2. So that we'll get every time the I value will be even only. Okay, and inside that we are checking whether that I is divisible by k or not. If it is divisible by k, then you are adding that to the sum. Okay, so at the end, after completion of the loop, you return the sum value so that it will be displayed in the main. Okay, so any doubt in this? Any doubt? Hello?
No, ma'am.
No, ma'am.
Oh.
No, ma'am.
Next, go to the problem 4. So problem 4 is a pattern printing problem. A pattern printing problem. So you are given an n value and you need to display those many lines in this format. So first line, second line, third line, like that n lines you need to display. If n value equal to 5, you need to display 5 lines. If n value equal to 3, you need to display 3 lines. So n lines you need to display, and in each line. So when you are writing this pattern problem, you need to remember that not only this particular pattern, you can write any type of pattern. So first, generally we'll have a 2 for loops when you are printing your pattern. So the first for loop will always indicate how many lines you need to print in your pattern. How many lines that you need to print in your pattern. So that n value is already given to you. Okay, the n value is given as an input. So you need to put a for loop which will execute for n times. Okay, execute for n times. So let L be the current line number I am taking. So L equal to 1, L less than or equal to n, L plus plus. So here you put a loop which will execute for n times. And I am always taking, this is for, you can even start your loop from 0, but without having the confusion, always when you are printing your pattern, you start your line from 1, loop from 1, because we will consider like this. This is the first line, this is the second line, third line, fourth line, fifth line. So based on the current line number, we will write the formula, how your pattern is changing. So here, if you observe, in the first line, how many values are displayed? In the first line, how many values are displayed? Only one value. In the second line, 2 values. In the third line, 3 values. In the fourth line, 4 values. Fifth line, 5 values. Like whatever might be the current line number, those many number of values are displayed in each line. If you observe, in this particular pattern, what will be the current line number? So if the current line number is 1, only 1 value is displayed. If current line number is 4, 4 values are displayed. If current line number is 2, 2 values are displayed. So L values are displayed in each line, where L is the current line number. Okay? So that's why I'm starting from 1. Okay. So how the pattern is printed? It is starting from the current line number. So see, first line is started from 1. Second line is started from 2. third line is started from 3. So like that, nth line is started from n. If you observe, see, if you are in the fourth line, it is started from 4. Suppose if you are in the second line, it started from 2. So what might be the current line number? So it is starting from that. Okay. So that's why I have taken my L value. L is the current. I am considering that L is the current line number. N is the total number of lines. Always when you are writing the pattern, you need to verify everything in terms of the current line number and the number of lines. Okay. So let L be the current line number. N is the total number of lines. So N is given to you, and your L value is varying from 1 to N. Okay. So this outer loop, you should always put it for how many times, how many lines that you need to print. So n lines we need to print. So put a loop which will execute for n times. Okay. And in the inner loop, so you need to check out the current line. So L is the current line. So how many times the current line is to be repeated? No. So in the according to our given pattern, so in each line you need to display L value. In each line you need to display L value, and it should also start from L. It starts from L. Each time you need to decrease the value by 1 till you reach up to 1. Till you reach up to 1. So you take some loop variable from I equal to, it should start from L, and I less than or equal to L, I plus plus. So this loop is starting, sorry, I greater than or equal to 1. So you need to start at L and you need to do up to I value becomes 1. And each time you need to decrease the I value by 1. So that is the pattern is given like that. So if my current line number is 4, so it is starting at 4. Each time it is decremented by 1, and where it is stopping when it reaches to 1. When it reaches to 1, it is stopping. Let me check anyone. Okay. So the inner loop is written according to that. So what we are doing here, you print the I value. You print the I value. Print the I value. So this printf statement is executed for L times. L is the current line number. If the L value is 1, it will be printed only once. If the L value is 2, it will be printed twice. If L value is 3, it will be printed 3 times. Like that, based on L value, it will be printed those many number of times. So once this for loop is completed, second for loop, this for loop is completed, that means that complete line, whatever you have in that line, that complete pattern is printed now. For the current line, whatever that you need to print is over. So we need to move to the next line. So before going to the next line, if you check, so the next line is displayed in the next line is displayed in a new line. So before going to the next line, you print /n. Here, in the previous printf statement, what we are doing, just we are printing the value and giving a single space between each value. Okay. So in the same line, all the values will be printed here. Now we So it will go to the new line before we go to the next line. So to go to the next line, simply close this L loop so that L value gets incremented, so that we'll go to the second line and check whether this is the ending line or not. So if it is not ending line, then we'll print the second line. Then L value is increased, third line, fourth line, like that. So always, generally when you are going to print the pattern type of problem, you will have only two loops. Outer loop will always indicate the how many lines that you need to print, and inner loop will based on the logic that each line contains. Okay. Always we need to think of in terms of n and l only. N is the total number of lines. L is the current line number. Okay. Same thing every time. So L equal to 1. So L and J I have taken the loop variables. So those two are declared here. So L value is varying from 1 to n, and J value is varying from L to, why I have taken 2 here is, see here, how we are printing the value. First print the value, after that we are giving one space. So because of that, if I put it up to 1, here if I put it up to 1, so here after printing the each line, I will get a space. But in the given pattern, there is no space. In the given pattern, there is no space. So it was not matching the cases. If it will matching that space and then giving the wrong answer. That's why what I did is, so I need to put a space for each and every other value except the last value. Except the last value, I need to put the space for each and every other value. So that's why I am executing the loop till j becomes 2. So after coming out of the loop, I am printing the value 1, so that there won't be any space after 1. Okay, and then go to the new line. So I am executing the loop only up to here. So this one I am printing it separately because to avoid the ending space. Okay. Otherwise, the test cases were not passed. Suppose if I remove this and I put a 1 here, suppose if I put a 1 here and then I remove this statement, then what was the problem here? So this problem you will face it. You need to know that in many other cases also. Okay. So let us test. Actually, test cases were failed here. See, the test cases were failed here because here we got the same answer. If you check, we got the same answer, expected answer only we got, but even it is failed because, see here, you select this, then you'll know the difference. You select this particular line, see this line. So after 1 there is a space. If you select the expected line, there is no space after 1. See, there is no space after 1. Whereas the actual output that we got has a space after the last one. Okay, see here. In all the lines, after 1 we have a space because of this. Here, printf %d space we gave. So because of that, we are getting a space after the last, even though the answer is same, the expected and the actual output is same, the test cases were failed because of this space. Okay, so after last one, you should not get the space. So that's why I run the loop up to 2, and then after 2 there will be a space. At the end, I am displaying the 1 separately, so that there won't be any space after 1. Okay. So now if you test run, So all your test cases were passed. Okay. So you need to know, even though you got the same answer, why the test cases were failed is because of this ending stage. Any doubt in this?
No, ma'am.
Okay. Then move to the next problem. An Armstrong number is an n-digit number if the sum of its digits, each raised to a power of n, is equal to the original number itself. Write a function count Armstrong that takes the three integer pointers a, b, and count as parameters. The function counts all Armstrong numbers in between the value a and b both inclusive and stores the count at the pointer count. Function does not return anything. It stores a count Armstrong numbers at pointer count. Both values at pointer A and B are positive, and always A is less than B. No. So here we need to count the Armstrong numbers between the given range. Anju Kumar, I think you need to follow the same process how you are registering for the courses. Same way you need to register for the September term. How you are registering the other courses in the same manner you need to register. Okay. So the input given here is A and B. Two values are given to you. Say for example, A value is 10, B value is 150 or 200, say suppose. So you need to find out all the Armstrong numbers between 10 and 200. How many values are there between, how many Armstrong numbers are there between 10 and 200, including 10 and 200 also. Okay. So what is mean by an Armstrong number? Armstrong means, say for example, if you take a three-digit number, 153. So take each individual digits of that number and take to the power of how many digits you have in that number. Okay. So 3. So 3 cube. 3 cube plus 5 cube plus 1 cube. So if it is a 3-digit number, then you take a cube of it. Suppose if it is a 2-digit number, square it. If it is a 4-digit number, you take each digit up to the power of 4, like that. So how many digits are there in the given number? So take each digit of that number and take to that power. How much power? How many digits you have in this number? To that power you need to take it. Okay, sum of the each individual digits to the power of n. If it is equal to the given number, then it is called an Armstrong number. So 3 power 3 will be 27. 5 cube will be 125 plus 1 cube is 1. So which is equal to 153. Okay. So in this case, because this is a 3-digit number, sum of the cubes of each individual digits of a number is equal to the original number. So it is called 153 is called Armstrong number. Okay. Say for example, if you have a 25. So because in this, how many digits are there? Only 2 digits. So you need to take each digit power 2 only. Okay. So 5 square plus 2 square. Because only 2 digits are there. So nth power of each digit, where n is the number of digits in that number. So this will be 5 square will be 25 plus 2 square will be 4, which is equal to 29, which is not equal to 25. So it is not an Armstrong number. Okay. So squares of individual digits of 25 is equal to 29. If it is equal to the same number, then we say that it is an Armstrong. But they are not equal. So 25 is not an Armstrong number. So suppose if you consider the individual single digit numbers, say 1, 2, 3, like that up to 9. Suppose if you take any of these numbers, say 7. So you have only one digit in this. You have only one digit in this. So you need to find out only 7 power 1. Okay, 7 power 1, which is equal to 7. 3 power 1, 3. 2 power 1, 2. Like that, 9 power 1, 9. So all the individual single digit numbers, all the single digit numbers are Armstrong numbers. All the single digit numbers are Armstrong numbers. So 1, 2, 3, 4, etc. up to 9. All these are Armstrong numbers. Okay. So like that, sum of the individual digits power n is equal to the original number, where n is the number of digits in that number, then it is called an Armstrong number. Any doubt in this Armstrong number? Okay.
No.
We were asked to find the Armstrong number between the given range. You are given a range A and B. So between this given range, how many Armstrong numbers are there? That you need to find out. Okay. So I think so you need to start at 10. Take one by one value till you reach to the 200 and check whether it is an Armstrong number or not. So you write a for loop which will start at A and end at B, and each time you increase the loop variable by 1. And you check whether that loop variable is an Armstrong number or not. If it is an Armstrong number, you increase the count. That is the logic that we write here. Okay. So we simply write it like this. For I equal to A, I less than or equal to B, I plus plus. Okay. If here you write, if suppose if you have a function called Armstrong, which will check whether it will return true or false. If it is an Armstrong number, it will return true, otherwise it will return false. Okay. So if Armstrong of I, then you increase your counter. Suppose ENT is a counter variable, you increase the count. And initially you take your counter as 0. Counter equal to 0 you take initially. If it is an I is an Armstrong number, then you increase your counter. So then I will go to the next value and check like that. It will take each and every value between the given range. It will take each and every value between the given range and it check whether it is an Armstrong number or not. If it is an Armstrong number, it will increment the count. So at the end, it will return that count value, so that you will get the how many numbers are there between the given range, how many Armstrong numbers are there. So, but our problem, it is given that, so your function is not returning anything. Okay. So it is given that our function is not returning anything. Okay. So write a function count Armstrong that takes three integer arguments a, b and count as parameters, and the function counts all the Armstrong numbers between the values a and b both inclusive and store the count as a pointer count. So your function is not returning anything here. This is the function. Count Armstrong will count the values. So it is not returning anything. So, and what it is saying, it is taking 3 pointer values. This is the A value, A pointer, B pointer and a count. Count is also a pointer. So here from the main, we have called the call by reference. We have called this function by reference. What is mean by call by value and call by reference? What is mean by call by value and call by reference? See here, suppose I have a function which will take some integer value as a parameter. Okay. Suppose inside this I have increased the I value to I equal to I plus 3 and display my I value. I have displayed I value here, and from the main function, I have taken my I value equal to 5 and I have called this function fun of I, and I am displaying the I value here. After returning from the function, I am displaying the I value. Okay. After function call, I value I am displaying, and even before the function call also I am displaying something. Printf before function call I am displaying the I value. Okay. So what happens here? So first it will always, your function execution will start from main. So it will take I value as 5, and it will display before function call I value. So before, what is the I value? 5 it will display. how can I assign a new variable to store each digit? Means Ahmad, okay, I'll come to your doubt later. So before a function call, so it will display I value. So I value, I have taken it as 5, so it will display 5. So now when I call a function, so it will jump to the definition of this function, and here I value is copied as 5 and I is increased by 3. So it will display in the function, I value will be in function. So I value will be 8 because when you call the function, you pass the I value, so that I value is copied into the, so you will copy 5 and it is incremented by 3, so it will display 8 in the function. Then after completion of this function, again it will return back to this statement, and after function call, you will expect that I will be displayed as 8 because we have changed the I value, so it should display 8. But it will display 5 only. Why? Is here how we have called the function, by value of the variable. So when you call the function by value, what happens here is this I is different from this I. Say for example, the same teacher is teaching to 2 different classes. In this class, there is one person called Suresh. Okay? So when the teacher goes to this particular class, this is another class. When the teacher goes to this particular class, here also there is one Suresh, but this Suresh is different from this Suresh. Okay? So same way here also. So when you declare your I in this function, first it will allocate the memory. So it will allocate the memory to I. Say for example, 2000 location is allocated to this I. 2000 location is allocated to this I, and in this location it will store 5. In this location it will store 5, and this location is named as I, and this is the address, and then there it will store a value of 5. Okay, so when you call the function, again in this function we have a declaration here. Okay, so whenever it sees the declaration, so it will allocate a memory. So it will allocate a different memory location. To that memory location, it will copy the same value that it have received from here. So there also it will store 5. Okay. So as long as in this function, when I call I, it will always refer to this 3000 memory location only. Okay. So as long as I was in this function definition, as long as I was in this function location, if I am calling I means it will always refer to this memory location. So what happened here? I have changed the value of I. So this will become 5 plus 3 equal to 8. So that 8 is updated at this particular memory location. At 3000 location, the value is updated as 8. The value is updated as 8. Now, when it return back from this function to this function, here I means what is the memory location of I in this function? It is 2000. So what is there at 2000 location? 5. So after the function, when I display the I value, it will refer to this I, and that unchanged value it gets displayed. Okay, so that is the call by value. When you call a function, what happens is any changes that made to that variable inside the function, that will not be reflected in the calling place. When you call a function by value, so whatever changes that you made to the variable inside the function will not be reflected in the calling place. Okay, so how it will be reflected? When you return it. If you return it, then only it will be reflected. Say, for example, if you write it like this, I equal to function of I, and here you return I. You have written a statement called here return I. Then in that case, this will be reflected. This will be reflected here, and then modified I value will be stored. But returning the value is not possible in all the cases because your C function can only able to return a single value. Any C function will able to return only a single value. Suppose you want to return multiple values. Suppose you have written a function called swap function. To that you are passing two parameters I comma j. Okay, say j equal to 3. So you have passed the swap function I comma j. The swap function should interchange those two values. It needs to interchange those two values. Let us take a temporary variable equal to I is equal to j is equal to t. You have interchanged the I and j values inside this function. Say for example, inside this function you have interchanged both I and j values. So if you display I and j, so it will display I value as, so in the previous case it will display 5, 3. In the function it will display 3, 5, and again after coming it will display 5, 3 only. Because we call the swap function by value. So, and it is not possible to return both the changed values from here to here because the C function will always return a single value. Remember that. Then how to return multiple changes is, how to return multiple values from the function is by using call by reference concept. One of the ways. There are so many ways. One of the way to return multiple values from a function is by using call by reference. So when you are calling by reference, the reference means address. Instead of passing the value of the variable, we will pass the address of the variable. Suppose I is a variable, the address of the variable will be indicated as like this, and I. This indicates an address operator. This is an address operator. So what happens here? You are passing the address of I and address of j to this function. Okay? So the variable which receives the address will become a pointer. Hello? Somebody is speaking. Any doubt? The variable which is receiving the address will be a pointer. Okay? So it will be received like this. Pointer, how we declare a pointer? With the star. So it will be received like this. Instead of ij, it will be received like a star I, star j, pointer. It will be received like a pointer. So what happens when you declare a pointer? So we'll see the same example like this. Here, I value is 5, j value is 3. So it will allocate the memory locations. Say for example, I memory location is 2000. I is allocated with the memory location of 2000. And there we have stored 5. Suppose j is allocated with the memory location of 3000. and there we are going to store 3 initially in the main function. Now, so we call the function with address of I, address of j, and the receiving is a pointer. So what happens when you declare a pointer? What happens when you declare a pointer is, suppose if I declare int star I have written a declaration like this. So if I declare int a, normal variable and pointer variable. So this is called a, so when you declare a normal variable, this will be called static allocation. Your system, your compiler will automatically allocate the memory to this. So when you declare a variable, it will automatically allocate the memory to this variable. So that is called a static allocation, static memory allocation. So but when you declare a pointer, your system will not allocate the memory. So you need to allocate the memory using dynamic memory allocation function, like MALLOC, CALLOC. Like that, there are some dynamic memory allocation functions will be there. So you need to allocate the memory using dynamic memory allocation. Okay, so that means always generally we use a pointer to point to the address of a particular variable. So I is an integer pointer, it will be pointing to the address of integer variable. Okay, so if I say a equal to 5 here, so if I say I equal to and a, I is a pointer, integer pointer, which is pointing to the address of an integer variable. So now that means both your I and A are pointing to the same address. Both are pointing to the same address. So here my I address is 2000, J address is 3000. So if I say and I and J, so this receiving pointer is, you can call it with the same name or a different name also, no problem. So if you call this as AB, that is also no problem. So this A and this I are pointing to the same address because it is a pointer, it won't allocate the memory to A. But A is pointing to the address of I and B is pointing to the address of J. So the same memory locations are pointed now. Now if you interchange at these two addresses, so 3 will go here, 5 comes to this, and when you return back here also I and J are referring to the same memory and that memory has changed. So you will get the changed value as your output. Okay. So if you want, so how if you want to return the multiple changes from the function, you need to pass them like a reference address. You need to pass so that it will return the whatever changes you made inside the function, that will be returned back to the calling place. Okay. So but when you receive like a pointer, you cannot say here AB. You cannot say like AB, I equal to A equal to B, A equal to B, B equal to T. You cannot call them as AB like normal variables because your A and B are the pointer. Now how to access the value of the value with address of a variable, like with the pointer, how to access the value at that address is another star operator. If A is a pointer, if you want the value at that address, pointer means address. If you want value at that address, you need to use one more star. So you need to write the code like this. T equal to star A equal star B equal to T. So you need to interchange because A we are pointer. To get the value at that pointer, we use star A because A is a pointer. Value at A is nothing but star A. Okay. So if you print the AB values, so what happens before calling you will get 5 3 as your AB values. In the function you will get 3 5 because we have interchanged 3 5 as the AB values. After coming from the function also you will get the output as 3 and 5 only. The changed value will be reflected in the calling place because of call by reference. Okay, you need not return it. Even though you didn't return, it will be returned because both are pointing to the same address. So that change will be reflected in the calling place also. That is the difference between call by value and call by reference. So in our example, they have given that this range, you see here, count Armstrong. To this function, we are passing 3 parameters. Those 3 parameters are the addresses, not like you are calling this function by reference, by passing the address of the variable. So when you pass the address, you need to receive like a pointer. So this is written to, this is one pointer, this is another pointer, this is another pointer. So A value, suppose if I want to access here, star A. B value if I want to access star B. So for loop is, it is starting from A, it is less than or equal to B, I plus plus. I is starting from A. So because here A is a pointer, you need to find the value of A as star A. So, and I am checking if I is an Armstrong number or not. If I is an Armstrong number, I am incrementing the count. Count is also a pointer variable. So, how to write this statement? Star count equal to star count plus 1. Because count is a pointer variable. Okay. And why I have given this initialized to 0? If I didn't give it, see here I have not initialized the count variable. So it may take some garbage value because it is pointing to a particular location, some memory location. If you have some any other garbage value in that memory location, that it will start from there. But initially we should see that your count is 0. So that's why I have initialized the count variable to 0. After that, between A and B, if I have any Armstrong number, I am incrementing the count. Okay. So, even though I have not written the count, that count when you display in the main, it will be displayed correctly because of count also passed like a reference. So, when you pass like a reference, whatever changes you made to that variable inside the function will also be reflected in the main calling place. So, that is main. So, whatever changes you made to count variable in this function will also be reflected in the main function because we are calling the count by reference. We are calling that function by reference. And how to check whether it is an Armstrong number or not? The same result. Like first we need to take what is the length of that number. How many digits you have in that number. How to check whether it is an Armstrong or not? So, suppose if you have 153 or 125 is your n, it is your number. So, what we need to do? First, we need to find out how many digits are there in the given number. So, how you will write that logic? While n not equal to 0, you divide your number by 10 and take the remainder. Okay. So R is equal to n mod 10. So when you mod with 10, always you will get the last digit. Okay. So your R will be the 5 in this case. Okay. So you take let p equal to power of, sorry, you are finding how many digits are there. Okay. Sorry. So n equal to n by 10. Each time you divide the number, it doesn't require this. Sorry. So each time you divide your n by 10 and increase your counter. Initially you take your counter to 0. Okay, counter to 0. While n not equal to 0, you increase the counter and divide your number by 10. So what happens here is, see this, how it get executed is. So initially my n value is 125. Okay, and count value is, initially it is 0. So the loop condition I am checking is n not equal to 0. Okay. So these are the variables I have taken. So 125. So n value is 125. So it will check the condition first. This is the condition. So it will check the condition. What is the condition? In the first iteration, 125 not equal to 0. So which is true. True means it will enter into the loop. It will enter into the loop and it will increase the count value. So count value will be 1 because count is 0 initially. Count plus plus means it will become 1. And what will be the n value for the next round? What is the n value for the next round? So it will be n by 10. 125 by 10 means it will be 12. Quotient only because both are integers. 125 and 10 both are integers. So it will take integer division. So it will take 12. So 12 not equal to 0. So then it is true. So it will increase the count to 1 more. So previously it has 1. Now it will 1 plus 1. It will become 2 now. And then n equal to n by 10 means now your n will become 1. 12 by 10. 12 by 10 means coefficient is 1. Okay. So 1 not equal to 0, which is also true. So it will increase the counter. 3. And n equal to n by 10 means 1 by 10 is always 0. So when it becomes 0, so 0 not equal to 0 will be false and it will stop. By the time it comes out of this loop, count is the number of digits in that number. How many digits are there in this number, you can find out using this logic. Okay. So first we are calculating how many digits are there in the number, in our number. So n is our number. So how many digits are there in our n, we are counting it using this loop. So here what happens when I complete this particular loop, my original number becomes 0. So but I need to keep track of my original number. So that's why I am storing the number into another variable num. So again I restore back num into n. So you will get original number. So in this loop n will become 0 and again I am restoring my original number in n. Now what we need to do to find it is an Armstrong or not. So we find the count is the how many digits we have. Now we need to take each individual digit of this number. So out of 125, so I need to take each individual. First take 5 power count plus 2 power count plus 1 power count. Like that each individual number you need to take and you need to power it up to the count value. So count is the number of digits in that number. So for that same logic we use. This same logic we use almost. Okay. While n not equal to 0, so first you divide the number and take the remainder. So when you divide the number by 10 and take the remainder, so you will get the last digit, this 5. So when you divide 125 by 10, so the same logic here I am using. So I am writing even R here. So first time it will be n. So this R will be inside the loop. Let me write it. Here let me write the R value. So what is the remainder after dividing 125 by 10? So the remainder will be 5. So now you need to find out the R power count value. So you can let P equal to find the power value, we can use POW function, which is there in math.h. Find POW of R comma count. Count is the number of digits in our number. So R power count value you take. So that means 5 power count is 3 in this case. Previously we counted, so count value is 3. So it will take the P value, it will calculate the P value as 5 cube. 5 power 3. Okay. Then n equal to n by 10. So now you add that power to the sum. You take one variable called sum. Sum is equal to sum plus P. So initially, before entering into this loop, you take some value as 0 because sum of the nth cubes of each individual digit is equal to original number. That we need to check out. So for that, you need to find out the sum. So when so your sum will be, what is the sum? It will be 125. Initially 0. Now 5 cube means P value is 125. So it will sum to 125. Then n equal to n by 10, so that the last digit will be omitted. This particular digit will be removed. Only it will take the quotient part. So 12. So 12 not equal to 0. So when you divide, you will get a remainder of 2. Last digit as a remainder, you will get it. So 2 cube. So you need to find out 2 cube. P value will be 2 cube. So which is equal to 8. So 125 plus 8. Which is equal to 33. 133. Okay. So again, it will divide the number by 10. So you will get the 1. And 1 not equal to 0. So it will take the remainder of dividing by 10. So you will get a remainder as 1. So you will get 1 cube. You need to find out 1 cube. So which is equal to 1. So 133 plus 1, which is equal to 144. So then when you divide the n by 10 again, so this will become 0. So 0 not equal to 0 is false. So it will come out of the loop. By the time it comes out of the loop, so sum of the nth powers of each individual digit is in variable called sum. Now you check whether this sum is equal to the original number or not. So original number we are storing into num and then came. So you check whether that sum is equal to the original number or not. So this is what I did here. So n power value I am calculating the result. I am stored in a result. So result will be result plus power. So n equal. So this logic. So now at the end I got a result. So the result I am comparing with my original number. So because in the loop n value is changing, we have stored that original number into some other variable. So num variable. So is it that sum is equal to the original number or not? We are checking. Okay. If they are equal, then it will return 1 because when the sum is equal to the nth power of each individual digit, sum of each individual digit, then that is an Armstrong number. If it is an Armstrong number, it will return 1. Otherwise, it will return 0. So if these two are equal, it will return 1. Otherwise, it will return 0. So in this example, both are not equal. So 125 is not an Armstrong number. Okay. So like that, what we did here. So first, we read AB and we have taken a count variable. We are passing by reference to this. So in this, what we are doing, initialize the count to 0, and we are running a loop which will execute from A to B. Each time you increase the counter by 1. So if you are checking whether that corresponding I value, all the numbers between A and B, whether they are Armstrong numbers or not, first you are checking by calling this function. If they are Armstrong numbers, you increase the count. Okay. So how you are checking whether it is an Armstrong number or not? So how you are checking whether it is an Armstrong number or not? So first you count the number of digits in the original number, how many digits are there, and then we are taking each individual digit and powering that to the count and adding to the sum. And at the end you are checking whether the sum is equal to the original number or not. If it is the original number, return 1, otherwise it will return 0. Okay. So how many concepts are covered in this example? You see, this call by value, call by reference concept. Okay, and how to access the value using pointer variable. So how you are accessing the value of the variable using pointer, and how to return multiple values from the function, and also so the logic of how to get each individual digit of a number and how to find the nth power of a number. So all those concepts were covered here in the same example. Okay. So any doubt in this? Any doubt, ma?
No, ma'am.
Well,
Let us see the last example. So in the last example, write a function binary to decimal that takes a long integer number b, represent a binary number. So binary number means it will have only ones and zeros, and an integer pointer. So to this function you are passing two parameters. One is the binary number, which is a long integer. Other is the integer pointer d. Okay. The function converts the given binary number into decimal and stores that equivalent decimal value in d. Okay, so this function, what it is doing, the b value, whatever it got, that b it is converting into decimal equivalent, and that value it will be stored in this pointer variable d. That means whatever changes you made to this pointer variable will automatically reflect to the main. So you need not return the result. Okay. So your task is, you will be given a binary number. You need to convert that into decimal inside this function, binary to decimal function. Okay. So how to convert a binary number into decimal? Suppose we have binary number as 101101. Suppose this is my binary number. Okay. So how we will convert this? we will take each individual digit.
Whose place value we will
So,
take?
so this first you take this. So because this is a binary number, so into 2 power 0. So this is the 2 power 0 coefficient. This is 2 power 1 coefficient, 2 power 2 coefficient, 2 power 3 coefficient, like that. Okay. So next plus, take the next digit. So 0 into 2 power 1. Okay, 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3 plus 0 into 2 power 4 plus 1 into 2 power 5. So we'll write it like this: 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 coefficients, 2 power 5 coefficient. So we will add all this. So 2 power, anything power 0 is 1. So 1 into 1 is 1 plus 0 into anything is 0 plus 1 into 2 power 2 is 4. 1 into 4 is 4 plus 2 cube is 8. 1 into 8 is 8 plus 0 into anything is 0 plus 2 power 5 is 32. 32 into 1 is 32. Okay. So this is equivalent to 45. So this is the binary number base 2, which is equivalent to decimal base 10. Okay, decimal base 10. So the logic that we have used here is, so you are getting each individual digit from this, from right hand side. So that you can do it when you mod with the 10. This number, when you mod with the 10, you will get the digit. Each time you divide the number by 10 so that this will be removed. So like that, mod with the 10 and divide with the 10. So that every digit you will get it, last digit get, and then after getting making use of last digit, you remove the last digit. So like that you do it till your number becomes 0. The same logic that we have used in the previous example. Now once we got this, so we need to increase, find the 2 power. So you take one counter which will vary from 0 to number of digits. Each time you increase that counter. So 2 power, that counter value you find out. So counter is initially 0, 2 power 0 it will calculate. Next time it will calculate 2 power 1. Next time 2 power 2. Each time you increase the counter. 2 power 3, 2 power 4, like that till you get the last digit, it will be incremented and you can use the power function to find the power of that. Okay. So, see here. So this is the logic we have used. So till your binary, B is the binary number, D is the decimal number. So initially the decimal equivalent is 0. So I have initialized with 0. So till your binary number becomes 0, what we are doing? You divide binary number by 10 so that you will get the last digit. The R is your last digit. So 2 power. So here I have taken my counter as I equal to 0. So first it will calculate 2 power 0. So this R, reminder, that means quotient into 2 power 0 it will calculate. Okay. Then next digit, and each time we are increasing the I value by 1. So next time it will calculate 2 power 1. Next time it will calculate 2 power 2. 2 power 3, like that. And this is the base, like a coefficient. You will get the last digit by dividing the number by 10 and take the remainder, and each time you are removing the last digit. Okay, so like that, it will calculate the decimal equivalent, and that you need to, that decimal equivalent value you need to store it into this pointer variable. So you are writing star d equal to star d plus this one. So when you, by the time you complete this while loop, your d will contain the decimal equivalent of your b. Even though you are not returning here, that will be reflected in this here, binary to decimal. After calling this, if you display the d value, the d will contain the equivalent decimal value, because d is a pointer here. D is a pointer. So you called by reference. So here you called by reference. So to this d, whatever changes you made in this function will automatically reflected to display, because of call by reference. So if you display the d value, it will display the decimal equivalent of that binary number. Okay. So any doubt in this? And here to find the power function, it is already given to you. Like you can use a built-in function also if you include math.h here. If you include a math.h here, you can even use a POW function. But math.h is not included. They have given the power function definition to find the power of a given number. So I am calling that function to find the power. Any doubt in this?
No, ma'am.
No. So like that, you can expect some problem on pattern, some problems on before control statement up to loop control statement, and some problems on functions, and pointer. Okay, so up to the 7th week. Okay. It was covered in the box. We covered up to 7th.
Excuse me, ma'am.
Hello.
Ma'am, I just wanted to ask one thing. Can I ask?
Yeah.
Like, ma'am, 2 days before, like, I've received a mail from my team regarding the OPP exam, and it's telling me like what is the duration of the exam and what is the like pattern of the paper. But ma'am, with that mail, I also received one more mail, which is telling me like you have to give the SST for like to give the OPP exam. So ma'am, like I have not received any mail regarding the SST uh, for the qualifier exam. So like what should I do? And ma'am, like there's one more doubt. Since like which is happening since morning. Like today the qualifier result should has announced, but like I'm able to see my result, but I'm not able to register for the course. It's showing me
You
like
contact the support team. You
ma'am,
contact the support team.
actually there's a meeting conducted by the support team since the morning, but like mostly because the result was declared very late. It almost came around 5, so the meeting had ended by that time, and the doubts were not be able to take care of the electronic students, but like as a result of data science students came early in the morning. Data science were able to like register also, and the further details were also being clarified for them. So I just wanted to ask like where there will be a class for the electronic students also, because the last registration date according to the mail is tomorrow only, and till now I am not able to find that registration tab, and not able to register for the further courses, and also not able to understand like whether I have to give the OPP exam and when that would be scheduled for me, anything else.
Have you got your like you are eligible for OPPE?
Actually, ma'am, the mail received was like the OPPO exam would be conducted, and this is like the following pattern for that exam. And in one of the mail, like we are going to declare the results soon. And if you are wanted to like, if you take up the computer science course, Introduction to C Programming, then there's you have to give the SST for that. So like regarding the SST, I have not received any mail, and there was a mail where which said that the OPB exam, the mock for the OPB exam has been released. So I have done that questions and like submitted them because deadline
No, that
tomorrow.
mark doesn't have any connection with your exam. So if you have other than a technical doubt, you have to contact the support team through mail.
Actually, ma'am, I have written them like almost like it's almost more than 10 times I have written. So there is no reply from them. And since morning, like I told you, there was a session. So, but like the result was only not announced till it came after 5. So, like the doubts were not taken for the electronic students. So I'm not able to understand like what should I do now? Like should I wait for the email for the SST? Like I've asked my seniors, so they are telling that there is a mail that comes for the SST, and you have to first qualify that, so that then you are only eligible to give that OPP exam. But
This
uh,
is not qualified. Just you need to submit a form like you are attending the exam.
uh,
That's all.
yes, ma'am. But
I,
like I have
that,
not received any form for that, and also like I was not able to register for the course till now. Like I am just only able to see my result, and it's showing me that you are eligible to join for the foundation course. And like after that, there should be some registration tab or something on which I should click for the registration, but I'm not able to see. And this is and I think, ma'am, this is the problem not only faced by me, but many more of the students are also facing this problem. And like after the writing to the support team, no message, no reply is there. So like, ma'am,
yeah,
can you
I will
help me
inform
out?
to the support team, but uh, I can able to clear only the technical doubts here. But I will inform to the support team that you people are facing this issue. I think they will conduct a meeting definitely.
Okay, ma'am. And like, ma'am,
On
regarding,
OPP create also, I think you will have some help. Oh,
okay, ma'am. And like,
that's
ma'am,
all.
regarding that OPP exam, so ma'am, there's a
Oh.
like code of conduct for that. Like first you have to first fill that SST form. After that, you are only able to give that OPP exam.
No, if you get a link, you can join. And but like to uh, even if you write, you may get absent because you have not filled that SSD form. Okay, so you first give the
There would be a
OPP.
mail. There would be a mail which I would receive. So like till date, so I'm not received any mail for submitting that SST form. Only the mail I have received about the OPB exam
Yeah,
pattern.
and that
And
that is support team can help you. So I can't help you, but I will inform to the support.
okay, ma'am. Thank you, ma'am.
Any other doubts, ma'am?